In 8.4, we're going to be working on volumes of rectangular prisms. Our key idea here is that the volume is the amount of space an object takes up, or sometimes it's referred to as the amount something can hold. The volume of a rectangular prism is the product, which we need to remember it means multiplication. So the product of the length, the width, and the height of the rectangular prism. That can look like volume, or V, is equal to length times width times height. Or sometimes you'll even see it written this way. V for volume, capital V, is equal to, when they use the capital B here, they're referring to the area of the base. And so in this case, of course, because it's a rectangular prism, the base would be considered an area. And so we would still use length times width for the area of a rectangle, and then we would multiply it by the height over here. So sometimes you'll see it written as the area of the base here with a capital B times the height, and that'll come especially down the road if you do other prisms and pyramids, not just rectangular ones. One thing you're going to have to get used to when we're working with volume here is that volume is measured in cubic units or units to the third power, and we'll, I'm sure, go over this several times, but that makes sense when you think about the fact that you're multiplying a length times a width times a height. So if these were all in, say, centimeters, it would be centimeters times centimeters times centimeters, which would be the same thing as centimeters to the third power. For example 1, we're going to be finding the volumes of different rectangular prisms, and the first one we're going to start with is here. So just like we did it in the geometry earlier, we're going to use formula, fill in, final. So our formula is going to be the volume is equal to length times width times height. So we're going to go over here, and again, it doesn't technically matter which one is length and which one is width. Height usually goes vertically like that, but because of our properties of multiplication, we can do them in any order. So we fill those dimensions in, and we end up with volume is equal to 7/8 times 1/2 times 5/8. It's not very often we multiply three fractions, so we can still look for cross-simplifying opportunities, but in this case, even looking in any direction diagonally, there really isn't anything that can go lower. So all we'll have to do is multiply our numerators across, and that'll be our new numerator, and then our denominators across. So since 7 times 1 is 7 and 7 times 5 is 35, that's going to go on top here. And when you multiply 8 times 2, you get 16, and then 16 times 8 would give you 128, so that's going to go on the bottom here. And because there weren't any cross-simplifying opportunities, we can kind of assume that that's as low as it can go. So what that tells us is the volume is 35/128ths, and remember, we're not done unless we actually put the label on here. And volume is going to be labeled in cubic units, so we can say meters to the third power here, or meters cubed is another way to read that. For letter B, we're going to be finding the volume of this particular rectangular prism. This one, you might notice, is actually a little different because all of the measurements are equal. So what that actually makes this is a cube when everything is equal. But we can still use the same formula if we want, because it's still a special type of rectangular prism. So we'll use volume is equal to length times width times height. So we'll fill in with volume is equal to 3/2 times 3/2 times 3/2. And again, you can look in all the different directions, but since you have to cross simplify diagonally, there aren't really any opportunities for that. So when you multiply across by your numerators, 3 times 3 is 9, and 9 times 3 is 27, so that goes on top. 2 times 2 is 4, times 2 is 8, so that goes on bottom. But we do have to recognize that this is an improper fraction because the numerator is bigger than the denominator, so we are going to have to finish by turning that into a mixed number. So 8 can go into 27 3 times, because 3 times 8 is 24, and that would leave us 3 left over, and then the denominator is going to stay the same. So the volume here is going to be 3 3/8 cubic inches, or inches cubed is another way to write that unit. This time around, we're going to do example 2 in class together, so we're going to go ahead and skip right to example 3 next. In example 3, we're going to be finding a missing dimension of a rectangular prism, and this is where your algebra skills are going to come in handy again. So they'd like us to write and solve an equation, again, remember I said algebra here, to find the height of this computer tower over here. So they give us some information. They say the overall volume is 1,792 inches cubed, and they give us a length, a width, but they don't know the height, and so they're going to ask us to find that out. So we're going to write an equation by starting with the same formula we've been using. Volume is equal to length times width times height, but this time we're going to fill in what we know, and we actually happen to know the volume. So we're going to put in 1,792. And again, it doesn't really matter which is which, but we're going to assume that the length could be one of these, like the 7 inches, and that maybe the height could be, or excuse me, the width could be like the 16 inches, so we would multiply by 16. And then what we don't know here is the height, so we're going to keep it as a variable, and just keeping it as h makes sense for right now. So in order to start simplifying or trying to solve this, we've got to multiply 7 by 16. So I set up the side math over here, found out that that's 112, and we're still multiplying that by h, but just like we did when we were solving equations before, we've got to get that variable isolated or by itself, and the way we're going to do that is to divide or do the inverse operations, and since it was multiplying here, we're going to divide by that 112. Oops. And if we divide by 112 on one side, we're going to have to divide by 112 on the other side. So we would notice that the 112h divided by 112 cancel those out and leaves us with just h down here. And then I set up the side math over here. So 1,792 divided by 112 will come out to 16. And so that would mean 16 would be equal to h. Or more specifically, we would say the height of the computer tower is 16 inches, and we're going to not cube it this time because remember the overall volume is cubed, so it would just be in regular old inches.